Hello and welcome to helpyourmath.com. In this video, we are going to graph linear equations in two variables. We're going to be given the equation, and when we're trying to graph a line, we either need 2 points of that line or more, or we need 1 point and the slope. So we need some information of that line. Most of the equations that we're going to see are going to be written in slope-intercept form. So slope-intercept form is y equals mx plus b. And what we're going to do with this is we're going to take this, because this is part of a point. This is the y-coordinate of a point that's on any linear equation. And this is the point 0, comma, whatever this value is. This is the y-intercept, so it lies on the y-axis. We're going to graph that point first. Then we're going to use the slope. Remember, slope gives us rise over run. And we're going to graph additional points. While the minimum is 2, it's always a good idea to graph 3 or 4. Make sure you have a straight edge available so that way you can connect them with a nice straight line. I do not have a straight edge on this computer. I do the best that I can. In our first example, we have y equals 2/3 x minus 1. So what I see here is that the slope is 2/3. That's the rise over the run. So for every 2 I go up, I go to the right 3. And the y-intercept is -1. So b equaling -1 is the ordered pair 0, -1. I'm going to start with that ordered pair, 0, -1. Remember, it's on the y-axis here. And now I'm going to use the slope to find other points on this line. Rise over run, so I'm rising 2, and I run 1, 2, 3. There's another point at 3, 1, and if I felt the need, I could check it and make sure that it does make a true statement if I plug in 3 for x and 1 for y. Again, I probably want to have a couple more points because I like for this to be as exact as possible. So I'm going to go up 2 again and to the right 3. And now if I go up 2 and over 3, I'm going to be off the graph. So the alternative to going up and right, which would be a positive over a positive, is I could do a negative over a negative. So positive 2 over positive 3 is equivalent to -2 over -3. Now I don't want to go here because if I start here, I'm going to end up back at this point. I'm going to go back to the y-intercept and graph a few points to the left of the y-intercept by going down 2 because of the -2 and to the right to the left 3. Down 2 and to the left 3. And these should make a straight line. If they make a V or if they make some other shape, something did not go right with this. And then again, you're going to use a straight edge. I'm going to do the best I can. Well, that was pretty good. And there's the graph of y equals 2/3 x minus 1. So all of the solutions, everything that would make y equals 2/3 x minus 1 true is on that line. I graphed some of the nice points, but even the points in between them, some that look less nice, like this point here, should also be a solution. In this example, we have y equals -2x plus 4. The slope is -2. Now I know fractions usually aren't people's favorites, but when it comes to slope, we actually want a fraction. So I need to turn -2 into a fraction. I can take any integer, such as -2, and turn it into a fraction by putting it over 1, right? Dividing it by 1 would still not change the value of -2. It's still -2. So I turn it into -2 over 1. That way I have a rise and a run. And the y-intercept this time is 4. That's the ordered pair, 0, 4. So I want to graph 0, 4. That's 0 left, right, but I go up 4. And then I'm going to use the slope to find additional points. The slope tells me I have -2 over 1, go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2. Alternatively, I see that 1 negative, it's in the numerator now, but we could also have 2 over -1, which would mean I'm going to go back to my y-intercept, and I'm going to go up 2 into the left 1. Up 2 into the left 1 just gives me additional points to the left of the y-intercept. Yeah, we get the idea. And so that's what the line would look like for this second example. The third example, for this one I see the slope. Wait, I don't see the slope. So what is the slope? Well, we can rewrite -x as -1x. So the slope this time, remember, it's not x. X is the variable, one of the parts of the equation, not part of the slope. The slope is the coefficient of x, and it would be -1. But we want this to be a fraction, so I'm going to put -1 over 1. Okay, so a lot of work with this one. And then the y-intercept, it says is 3. That would be the ordered pair, 0, 3. We're going to start with that y-intercept. So the y-intercept says don't go left or right, but do go up 3. And then the slope says go down 1 and to the right 1, down and to the right, down and to the right. There's a lot of these points. Or we can go back to the y-intercept and we could think of the slope as what? I hope you said 1 over -1 because you would be correct. And that would indicate rise 1 and go to the left 1. Rise and left, rise and left. And then using a straight edge, we would connect those and have a beautiful, gorgeous straight line. Question 4, we have y equals 4x minus 5. So again, we're given a slope that's an integer. I don't really want a slope that's an integer, so I'm going to put 4 over 1 to give me that rise over that run. And then what is my y-intercept? My y-intercept is -5, so that's the ordered pair, 0, -5. And so from here we're going to graph, start with the y-intercept, start with the point that you know. We're not going left or right, but we are going down 5. And now we're going to use the slope, so we're going to go up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1. We can see this is a very, very steep line. All right, 2 more examples. How you doing? You getting these? All right, good. I hope so. This time we have a slope that's -1/5. Now you have to decide where to put that negative. You either put it in the denominator or the numerator, but you can't put it in both. So we can think of it as -1 over +5 or +1 over -5. Use one of those two. Then we have a y-intercept of -8. And again, that's the ordered pair, 0, -8. So that's where this graph barely, it's all the way at the bottom. And now let's see. This is telling me to go down 1 and to the right 5, but I can't go down because I'm at the bottom of the screen. So while that slope is nice and we can usually use it, because I'm already at the bottom of the screen, I don't want to use that 1 because I have nowhere to go. So instead I'm going to use this version of the slope, which tells me go up 1 and to the left 1, 2, 3, 4, and 5. This one I can only get 2 points on this graph. If you are creating your own graph, you can extend the negative x-axis out, or you can extend the negative y-axis. But we're just going to use these 2 points and do the best we can. And whereas the last one was really steep, this one's much flatter. So it would be somewhere down there, and that should be a straight line. Last example. So the last example, this is the first one that's not in slope-intercept form. It's really helpful to get it in slope-intercept form, so let's do that by getting y by itself. The first thing I want to do is subtract 21x from both sides. Now these aren't actually like terms, so I can't really combine those. We're going to write -7y is equal to, and I like putting that minus 21x first, just because y equals mx plus b has that term containing x first. Divide both sides by -7. This is 3 divisions of -7. Each term gets divided by -7. Here we end up with just 1y, which we say is y. This is going to be positive 3x. This will be positive 2. So now we know the slope is 3. I don't want to use a slope of 3. I want it to be 3 over 1. And we have a y-intercept of 2. So we're going to write the ordered pair 0, 2, and we begin with the y-intercept 0, 2. Graph it there. Use the slope to find a couple more points. That's up 3, rise of 3, run of 1. Rise of 3, run of 1. If I want to graph points to the left of the y-intercept, I'm going to think about this as being equivalent to -3 over -1. So I can go down 1, 2, 3 to the right, left 1. Down 1, 2, 3 to the left 1. I think I can get one more in here. 1, 2, 3 to the left. It's another steep line, isn't it? It turned out pretty good. And that's how we would graph linear equations. I hope you found this helpful. Thank you for stopping by.